The topic is creation and enforcement of Kyverno policies inside a Kubernetes cluster. I will explain how I created and implemented those policies and importance of those policies inside a Kubernetes cluster. First, let's understand what is Kyverno policy, meaning what is the purpose of Kyverno and where does it fall in the Kubernetes concept. First, we must understand that there is a concept of STO service mesh where it says that there exists north, south and east-west traffic within the cluster, meaning north-south traffic is traffic that is outside, meaning outside users accessing the application, and to our east or west traffic is the traffic within the cluster, interpersonal communication between the resources, that is pods and everything, that is known as east-west traffic. So service mesh is a concept where that east-west traffic is managed, meaning it is managed by providing TLS certificate security and monitoring benefit. How it does? There is a concept inside the STO service mesh or service mesh, that is admission controllers or dynamic admission controllers. STO mesh providing its services or benefits comes by it creating a sidecar container besides our main container, meaning there would be two containers that is running. One is the main container or your application and another would be the sidecar container, and it is created hand in hand on the fly, which is related to admission controllers, that is dynamic admission controller. Dynamic admission controller is a concept where request to the Kubernetes API server is intercepted before it reaches the etcd, that is the database. By doing so, it gives us more privilege and more powers to either validate or to mutate, which is creation, deletion, modification of objects and requests. Basically, the concept of service mesh and dynamic admission controller and everything in between is related to giving us more powers and privilege to access and control our Kubernetes cluster. It provides TLS security, enhanced monitoring, more control in managing the compliance and security concept related to Kubernetes cluster. Now, as we know about service mesh and dynamic admission controller or admission controller concept, we can understand the Kyverno policies. Kyverno is an open source tool platform that is used to enforce and provide policies and security, which replaces or is a simple alternative to us writing the complex admission controllers by ourselves. Meaning, if we were to write admission controllers or dynamic admission controller webhooks to implement those validating or mutating and interception of Kubernetes API server to enforce certain policies or related to security and storage or compliances, we would have to learn Go language and then implement and create such policies of admission controllers and dynamic admission controllers. So Kyverno is an alternative, that is where we create a YAML file with certain syntax of Kyverno which is provided in their website, and we enforce such policies, which replaces the headache of creating dynamic admission controllers or admission controller policies. Now in this tutorial I will be implementing 3 Kyverno policies. First is Disallow privilege policy, meaning it is a set of rules that is enforced by Kyverno to prevent workload from gaining administrative control over containers and underlying nodes. So this policy will prevent containers from running in privilege mode or in the root mode. Second is Kyverno pod CPU and memory policy. This is a set of rules and policies enforced by Kyverno to restrict or ensure containers inside the Kubernetes cluster are deployed within defined computing resources. Meaning, instead of leaving resources allocation or not specifying such information while creating deployments or YAMLs, this policy validates that every container must specify request and limits for both CPU and memory. Simply, it will not let you create a pod if its resources, CPU or memory is not specified in the deployment file or the YAML file. And third and final policy is Kyverno image policy. This is a set of rules that says container images running inside our Kubernetes cluster must meet the organization's security, compliance and supply chain integrity standards before they are allowed to be created or updated. Simply, it is specifying authorized resources, more specifically defining your organization's image registry, and it only allowing you to pull images within those specified sources. If it is besides that or not specified, it will not pull the images. So these are the policies. Now let's begin. First command is to start the Minikube. I performed Minikube start with the memory and CPU specification, that is 5.6 GB and 4 CPUs. It was successfully started. Now next is to add and install Kyverno. The command I used was helm repo add Kyverno with its link and helm repo update, then followed by helm install Kyverno with this command and creating Kyverno namespace within it. It was successfully created and deployed. I confirmed it by performing kubectl get pods -n for namespace Kyverno, and it showed all these required pods with respect to Kyverno, that is up and running. Next, we will perform all these three actions without these policies, and we will confirm that it is letting us create or perform these commands without those policies or rules. Meaning I will create a pod with privilege true, meaning I will add privilege that is true inside the YAML file of the pod, and I will run the pod with no resources specified, and I will pull the image without specifying the repository or image registry. For this, I first created privilege.yaml to create a pod with privilege access. This was a pod specification file. Then I switched into Kubernetes directory and I applied YAML file with Kubernetes kubectl apply -f with privilege.yaml, and it was created, and I confirmed it with kubectl get pods, and it was up and running with privilege access, that is true. And for second, I performed kubectl run no resource pod with the image nginx, meaning no resources has been specified while creating this pod. I confirmed it with kubectl get pods, and now both of these pod are up and running, meaning privilege access pod and no resources specified pod, both are up and running. And third and final was kubectl run docker hub pod with image nginx latest, meaning there is no specification of registries. I confirmed it with kubectl get pods, and all these three pods were up and running, meaning these three policies were not applied until now. So without these policies, these pods are running. Privilege pod with privilege true, meaning it is having privilege access or permissions, and second is no resource specification while creating the pod. We have not specified memory and CPU allocation while creating this pod, and it is up and running. And third is no direct specification of registries authenticated and within the compliance of your organization, which is nginx, that is created. Now let's implement these policies, that is Kyverno policies, one by one and apply these commands again to see if these policies works or not. So the first YAML for this policy is disallow privilege official YAML. So this is the format which is officially available in their Kyverno site. I have also used the same format from it, or the template from it. This policy is to disallow privilege access or permissions to run in privilege mode. Simply, this policy ensures pods do not call or run in privilege mode. Here's the important part. We can observe that there is a statement validation failure action which is mentioned enforce. It is by default audit. Audit means it will allow you to run this or perform your commands and everything, it will work fine, but in the background, in the logs, you will see that this policy is working. It will allow you to perform the actions, but in your logs you can see that policy is working, but when it is enforced, it will not allow you to perform the action. So I kept it as enforced, so we can observe this policy in action. That was the first policy. Now for second policy, this is the same template or the format on this site, and I kept it same enforced, so we can observe that it is working or not while performing the command. So this policy, which is required resources YAML, it is to ensure every container is defined by CPU and memory request and limits to prevent resource starvation or node crashes. So it also has the message CPU and memory request are required. Now let's apply this YAMLs or these policies. I performed kubectl apply -f required resources YAML, kubectl apply -f disallow privileged official YAML, and it showed that cluster policy Kyverno, these two policies are configured, meaning it is running. To confirm it, I performed the same commands again. First, I deleted the previous pod performing kubectl delete pod privilege pod, and I applied that same privilege YAML pod again. Now it shows error from the server, and it shows error when creating privilege.yaml. It says admission webhook validate.kyverno.svc fail denied the request, and it says it was due to the following policies. The policies is disallow privilege containers. It says validation error privilege mode is disallowed. So the pod which we have created in the YAML, it has privilege that is true, so it is not allowing us to create the pod that has privilege access or mode that is true. Now for the second policy, I performed kubectl run no resource pod with the image nginx, and again it showed the error from the server with the admission webhook validate.kyverno.svc fail, that is denied the request because it is enforced. So it says it is due to the following policies: require resources, require request limits, validation error CPU and memory request or limits are required. So these two policies worked and we have implemented it. Now for the third policy, which is specification of registries, simply image registries in specified compliance authenticated by your organization or company. In my case, I would be implementing this image within my GitHub account registry. To do that, my plan is to first push the image from Docker Hub to the GitHub repository, and then create a policy that enforces to only pull images from the exact same GitHub account of mine or GitHub image registry of my account. To perform all this, first it is to create personal access tokens. So I head back and logged into my GitHub account, and I created the token with the name image push with read and write packages checked. Then I created that personal access token. Then I head back into the Docker Hub. I logged into it. Then as you can see, there is the image that is being pushed, which is Kaif Mohammad Khan 123 / resume-matcher-devops. My aim is to push this image into my Docker image registry. To do that, I perform the command that is echo with the personal access token created or generated by GitHub pipe, that is followed by Docker login GHCR.io, which is GitHub container registry, followed by -u, that is username of my GitHub account, which is Kaif Mohammad Khan, followed by password of GHCR GitHub. Then it was successful login. Then I performed Docker tag with Docker tag Kaif Mohammad Khan 123 / resume-matcher-devops latest, which is my Docker pushed image into the GHCR.io, that is GitHub container registry, followed by my username and the name of the image, that is resume-matcher-devops latest. After tagging it, I perform Docker push. Docker push GHCR.io, followed by my username and the image name. It was successfully pushed. After this, I head back into my GitHub account and I checked the packages section, and it was successfully pushed into the packages section, meaning it is successfully pushed into GHCR GitHub container registry. Then next is to update deployment file to only use images within that registry. To perform that, it is for us to create a secret. So I head back into the GitHub account again, and I created the token with read packages, and then I created the secret by performing kubectl create secret, which is Docker registry aiming GHCR secret, which is specifying Docker server, that is GHCR.io, username which is Kaif Mohammad Khan, and Docker password, which is the token I created or generated. The secret was successfully created. Then I updated the deployment.yaml file with default image pull with image pull secret section. So I added image pull secrets with name GHCR secret. Then I applied this deployment file by kubectl apply -f deployment.yaml. It was successfully configured. Then I created the restrict image registries YAML file, meaning Kyverno policies to restrict image that is outside our organization. It's the same, I enforced it, and the policy says that images from unknown public registries can be dubious quality and may not be scanned and secured, and it will give a message unknown image registry if it shows error. And in the rules you can see it is validate the registries, and below we can see or observe that we have specified GHCR.io with our username Kyverno Khan. That is for ephemeral containers, initContainers, and containers with the pipe docker.io library and Postgres. So if it is not within this specified registries, it will not allow us to create or run with other images. I saved this YAML and I applied it with kubectl apply -f with the name restrict image registries.yaml and ClusterPolicy Kyverno.io, which is with this name was created. Then to validate or check it, I perform the command kubectl run docker hub pod with specified image nginx, which is not within the specified registries, with the command override, and the below is to specify container size and memory because of the other policies we have implemented. Meaning if we were not to implement the memory and CPU resource policy, I wouldn't need to specify this information while performing this command. Since we have created another policy for specifying CPU memory, I have to specify with these constraints and information, that is memory and CPU, to run this. I ran this command and it showed error from the server, that is admission webhook validate Kyverno SPC fail, which is denied the request, which says it was due to the following policies: restrict image registries, which says validate registries, validation error, unknown image registry. So since it was not within the specified image registry, that is ghcr.io/Kyverno Khan, which is within the docker.io library and Postgres database, is not allowing us to run this pod with other images. So that is it for the video today. I hope the topic was simple and insightful. Make sure to let me know if you have any questions in the comments. Thanks. Have a good day. Bye.